My name is Tom Mens. I'm a professor at the University of Mons in Belgium, where I'm leading the software engineering lab. And together with Alexandre Decan, who is a postdoc researcher in my team, we are doing research on the use of specific version numbers in packages in large software package distributions. Let me first start by explaining what we mean by a software package distribution. Essentially, it's a large collection of tens of thousands, often even hundreds of thousands of interdependent packages. Each of these packages has multiple releases, and these releases are linked to each other by means of explicit runtime dependencies that are constrained by so-called versioning constraints on their dependencies. These packages are distributed through package managers that might have different versioning and release policies. The three package distributions that we have studied as part of this research are Cargo for the Rust programming language, NPM for the JavaScript language, and Packagist for the PHP language. We can see that there are three huge ecosystems that in terms of number of packages count between tens of thousands and hundreds of thousands of packages, even more package releases, and yet even more dependencies that may range into the millions. The releases of these packages in these ecosystems, they use a 3-digit version numbering strategy based on the semantic versioning policy. If you want to signal that you have only made some patches or bug fixes, you just increment the third number of your version. If you want to indicate that you're making minor changes that are backward compatible, you will upgrade the minor version number. And if you want to indicate that your changes might be backward incompatible and might lead to breaking changes, you will upgrade the major version number. Packages that depend on such package releases may specify whether and how they want to remain up to date. Either you can specify a dependency constraint that is strict. In that case, you will not allow to have automatic updates of your dependencies. If you use the tilde constraint, you will only allow patch updates. The caret constraint allows you to accept all minor updates. This means that you're unlikely to have breaking changes. And the most permissive strategy might be dangerous to use because it can lead to breaking changes. Now, the main question that we wanted to look at is to which extent the major version 0 is different from a version number that is higher than 0. So this is often termed as the so-called magic 0. The popular convention for a 0 version number is that it actually represents an initial development release. So it's something that's not yet ready for production, while any package that has a major version number that is 1 or higher would correspond to a stable and production-ready package release. Now, is this really the case in practice? This is what we wanted to find out in this empirical study. To already provide you some initial evidence, so this common wisdom is not necessarily always true. For example, take the ZeroKit Web SDK package in NPM. That the latest version is 4.0.6, which is clearly higher than 1.0. So one could consider and argue that it's mature and stable. However, if we look at its characteristics, which we see that in its entire lifetime, it only had 5 different releases, 16 commits. It always had a single developer contributing to it. Moreover, it is no longer maintained today, so one could hardly call it mature and stable. On the other hand, Axios, which is today in its version 0.19.2, so clearly it's still in the 0 version range, so one could argue it's not production ready. This does not seem to be true because it has had 42 different releases over its lifetime, almost 1,000 commits, more than 200 persons have been contributing to it, and even more importantly, it has had over 10 million weekly downloads. It's more than 36,000 other NPM packages depending on it, and more than 2.6 million GitHub projects using this package. So clearly seems to be a stable and mature package. I hope, otherwise there wouldn't be so many packages and projects relying on it. Now, there is a problem of the 0 versions in the different packaging distributions that we have considered, because there is specific rules and policies that are different for the 0 version range than there is for the major versions that are 1 or higher. If we look at what the semantic versioning policy dictates, then it says that basically if you use a major version 0, it is supposed to be for initial development only, and any type of change to your package might lead to breaking changes, so it's really not considered stable. These three ecosystems that we studied, Cargo, NPM, and Packagist, seem to be more permissive than what semantic versioning dictates. What they do is simply a shift in the interpretation of semantic versioning. They consider the minor version as the one that will lead to breaking changes, while if you upgrade simply your patch number, it is accepted as a change that will still be backward compatible. A difficulty in analyzing the results is that different packaging ecosystems are having a different interpretation of the usual way in specifying dependency constraints. How to interpret the tilde notation or the caret notation might differ from one ecosystem to another. I will not go in details on this here. If you want to know more, I can refer to this recent IEEE Transactions in Software Engineering paper that we have published. What we can see here is that everything in green is more permissive than the semantic versioning policy. Everything in red is more restrictive than what semantic versioning policy dictates, and everything in white is semantic versioning compliant. When we look at the tilde constraint, then we see that the tilde constraint is actually more restrictive than semantic versioning because it only allows patch updates. The caret constraint is compatible with semantic versioning because it allows both patch updates and minor updates. But this is only true for versions that have a major version 1 or higher. Strangely enough, for the 0 major version, the interpretation of tilde and caret is actually identical for all three considered ecosystems. We do see that if your major version number is 0, the way in which tilde and caret should be interpreted is different from when your major version is 1 or higher. So this leads to quite a lot of confusion with developers. You can also find lots of complaints on the internet that whenever you're having packages that are using 0 version number, that they tend to get stuck in this 0 version space for quite a while, and that it's not really recommended to do so because it gives the feeling that these packages are not stable. So we set out to answer the following research questions. First of all, we wanted to find out if the use of package releases with a 0 major version number is prevalent in these three different package distributions that we studied. Then, for those that have a 0 major version release, we wanted to know how long does it take before the package actually reaches major version higher than or equal to 1. A third question that we wanted to answer was, if we assume that package releases with a 0 version number are in initial development, then we would expect them to be updated more frequently than packages with a higher major version number. The fourth question is related to the first. While the first one looks at whether package releases that are still in major 0 version number are prevalent, the fourth question looks at whether such package releases are actually often used by other packages that depend on them. And then finally, the fifth one is related to the semantic versioning policy. What are the types of dependency constraints towards package releases with a 0 version number? Are these dependency constraints semantic versioning compliant, or are they more permissive or more restrictive? So let's start with the first question and look at the prevalence of package releases within the 0 major version range. If we look at the data, then we see that in the majority of cases, especially for cargo, like 9 out of 10 packages are actually having a major version number 0. So it's really a really high number. Almost all package releases are still in the 0 version names. This is quite different from the other ecosystems. While in NPM it used to be the case a couple of years ago, the proportion of packages in 0 range has been gradually going down until it reaches like a factor of 50% or so. For packages, it has always remained more or less stable over time at a level of around 30%. So the use of package releases within the 0 range is quite prevalent for the different considered package distributions, but we see a lot of variation in the proportions. So now the second question we wanted to answer was, how long does it take for a package that is still in the 0 version range to actually reach a major version 1 or higher? This is to find out if we can find evidence that packages tend to get stuck in the 0 version space. Apparently this appears to be the case, because if we see this figure, it shows the proportion of packages within the 3 different package distributions according to 3 categories. Those that have always remained with a major version 0, those that have always been with a major version 1 or higher, and those that have been first in a 0 major version and then moved to a higher version. We see that the majority of packages in Cargo, 92% has always stayed in the 0 version range, so they actually indeed get stuck there. For NPM it's the same. If you are in 0 major version, you will tend to stay there. That is about half of the packages. The other half have started already with a first release that was higher than 0. And for packages, it's like 1 out of 3 packages that always remains in the 0 version range. There's actually a very small percentage, like 1 out of 10 packages, the green parts you can see in this bar chart, that actually migrated from a 0 major version to a version that's higher than 1. For these packages that actually did the migration from 0 to a higher version, we looked at how long it took them to reach this higher major version number. These graphs show it. So the left one is showing it in terms of time a package needs to migrate to a version higher than 0. And the second picture shows this in terms of the number of releases required to do this. What we see that on average, it takes a couple of months and a few updates to be able to get out of the 0 version space. But for many packages, it takes even much longer. If we take, for example, 1 year, which is about here, then there is still 20% left. So this means that about 1 out of 5 packages took more than 1 year before they were actually managed to go outside of the 0 version space. And even in 1 out of 10 packages, so that's a 90% here, it took more than 2 years to reach a higher version than 0. So it can take quite a long time to reach version higher than 0, and in many cases these packages actually never reach such a version. The next question was about the frequency at which packages in the 0 version range are updated. If we assume that major version 0 is all about rapid development, one would expect that packages in the 0 version range would be updated more frequently than the packages that are in the version range 1 or higher. These boxon plots show the difference for the 3 considered ecosystems in the time it takes in days between consecutive updates for the 0 version range and the version range higher than 1. And basically we cannot really observe a big difference between them. We did find statistical evidence, but we computed the effect size and it was small to negligible. So although packages within the 0 version range are updated more frequently than packages in the 1 version range, they tend to do so only slightly more frequently with small effect size. So for all practical purposes, one could say that the difference is not enough to really say that we can find a big distinction between how packages in major version 0 behave compared to the packages with a higher version number. The next question is related to dependencies towards packages that are within the 0 version range. The assumption is that if you have a package that is already considered stable, so it is in production, and this means that it should be in a version 1 or higher, then in order for it to be stable, it should not depend on other packages that are still in the 0 version range. So the first thing we studied was if there are many packages that are still in the 0 version range that are required by packages with a version 1 or higher. And we see for the 3 different ecosystems that the percentage of packages that are in these cases can be relatively high. It ranges from 6% to 16% of packages in 0 version range that are being required by packages with version 1 or higher. We also studied it from the point of view of the source packages. So how many packages that are within the 1 version range or higher are we still relying on packages within the 0 version range? It ranges between about 6% to 20%. So this is still a considerable number. So it's rather frequent that packages with a version 1 or higher are relying on packages with a version 0. So the next question is related to semantic versioning. According to the semantic versioning policy, if you have a package that is in version 0, it's considered initial development. So this basically means that anything may change at any time. So even patch updates of these packages might be backward incompatible and might lead to breaking changes in its dependencies. On this basis, one would argue that all dependencies to such packages that are still in the 0 version range should use strict dependencies. However, as I explained before, the 3 different ecosystems that we studied, Cargo, NPM, and Packagist, have a more permissive versioning policy, and this is clearly seen here. Also, all patches of packages in the 0 version range are assumed to be backwards compatible and so will not lead to breaking changes. We can clearly see that all dependencies to such packages, they allow patch updates, about 96%, so almost all packages for Cargo, 73% for NPM, and 73% of packages. So clearly, these ecosystems are more permissive than what semantic versioning dictates, because patches of the packages within the 0 version range are still expected to be compatible. So in summary, we have seen that package releases in the 0 range are really very prevalent in all 3 different packaging distributions, and in Cargo they contribute even to 90% of all of their packages. We also see that packages tend to get stuck in the 0 version space for the 3 considered ecosystems, and only a small fraction of the packages actually goes to version 1 or higher. And if they do so, it might take between a couple of months until sometimes more than a year to do so. We didn't really find big difference between the speed at which packages are updated when comparing packages within the 0 version range and version 1 or higher. We also didn't find any practical difference between dependencies to packages within the 0 range and packages within the 1 range. And finally, when we looked at the semantic versioning policy, we found that package releases within the 0 range, they seem to adopt a policy that is more permissive than what semantic versioning is dictating. So, to conclude this presentation, I think we can clearly say that we found that the popular belief that packages within the 0 major version range are for initial development does not really appear to be true. In fact, we observed very little difference between how package releases within the 0 version range are behaving compared to packages with a major version 1 or higher. What we did find was that there is quite some confusion. First of all, because of the way in which dependency constraints are being used by package managers. So the caret and the tilde constraint have a different interpretation depending on whether they are used for packages within the 0 version range or the 1 version range. And secondly, that semantic versioning is actually too strict when it comes to packages within the 0 version range, because all of the 3 studied packaging distributions, they follow a more permissive policy for such packages. So to conclude, there is not really any fundamental reason to consider that package releases within the 0 version range should not fulfill the same contracts or promises as package releases within the 1 version range do. Well, with this, you can see that I reached slide number 1.0. So this terminates my presentation, and I'm open to receive any questions from your part. Thank you.